All right, this is a brief tutorial on scientific notation. So we can see that scientific notation is a number between 1 but less than 10 of a number times a power 10 to move the decimal place into the right position. We can see from these examples, we got 3.2 times 10 to the third is 3200. We got 2.7 times 10 to the negative fifth is 0.000027. So we can see positive number and the exponent means a number is going to be large. Negative number in the exponent means the number is going to be small. Practically speaking, if we take our 3200, decimal place is going to be right there. We're moving it 1, 2, 3 places. 1, 2, 3 to get the decimal place in the right position, which leads us to 3.2 times 10 to the positive third. So we move that decimal to the left and you get a positive exponent. Now, same thing, if we take our 2.7, the decimal place is right there, so we're going to go 1, 2, 3, 4, 5. So now the decimal place is there, so we add our zeros in. And so be 0.0000027. Notice the number of zeros is 1 less than the negative exponent. So we want to write these numbers in scientific notation. So if we notice we got 1, 2, 3 places to the right, so that's going to be negative exponent, so 2.35 times 10 to the negative third. Here, this is a large number, so it's going to be a positive exponent. So it's the decimal place is there, 1, 2, 3, 4, 5. So it's going to be 2.3 times 10 to the positive fifth. Here we got a negative exponent, so 1, 2, 3, 4, 5. So with the exponent there, or the decimal there, we'll have 5.46 times 10 to the negative 1, 2, 3, 4, 5. So negative 5. 437.0, we're going to say 1, 2. It'll be a positive exponent, so 4.370 times 10 to the second. And notice this 0 I kept because when you see a 0 after the decimal place, the only reason to write that is to indicate the precision of your measuring. And so the only reason to put that is that I know it to the tenths place and it just happens to be a 0. Now, let's do it the other way. So we got numbers in scientific notation. We'll put them in the more traditional numbering format. So if you say 7.2, you're going to move the decimal 4 places. So 1, 2, 3, 4. And so the decimal's going to be out there. So we're going to have 72,000. If we count it back 1, 2, 3, 4. So we're good. Now this is to the negative thirds, 5.20 times 10 to the negative third. So if we got 5.20, we're going to go 1, 2, 3. So now the decimal point is there and you fill in the 0. So we got 0.00520. 4.50 times 10 to the second, so you get your 4.5, and we move it 1, 2 places. So now the decimal place is right there, so we've got 450. 8.6 times 10 to the negative seventh, so we get 8.6, so we're going to move it 1, 2, 3, 4, 5, 6, 7. So now the decimal's there, and we fill in the zeros. So what that's going to be is 0.000000086. Again, notice I've got 6 zeros between the decimal and the 8, which is one less than the number of decimal places I'm moving. So that's a good way to keep up with it. All right, this has been a brief tutorial on scientific notation.